In this video, let us redo our look controls, but instead of using the mouse, let us use a controller. So just to start, to make this work kind of easy for us, I currently have my controller plugged in, and I'm just going to make a new boolean, call it something like using mouse, or let's call it mouse enabled. And we'll default this value to false for now because we're not going to use our mouse. But really, all we want to do is make a branch node in the tick. And if our mouse is enabled, let's run the mouse enabled code. If our mouse is not enabled, well, then let's run the false line, which is going to be our controller. So this is really just checking for rotations. Are we going to be using our controller or are we going to be using our keyboard? Okay, so let's start by adding our IA look. Input action look. What did I call it? Okay, it was called IA aim. There you go. So let's start by adding this in here. And what we want to do is when the action is triggered, that means we're looking. When it's completed, that means we've let go of the stick. So we can really see that by printing a string. We'll call it active. And on completed, we're going to print a string and we'll call it deactive. Let's just check if this works. So I move my right stick, active, I let it go, it says deactive. Okay. That'll come handy later. But really, when it's active, what we want to do is we want to get what rotation our player needs to be at. So I'm going to make a function for this just to make it easier to call later. And we're going to make a function and call it update aim rotation. And in here, I want to have two inputs. Or really, we can just have one input. We can call it look xy and make it a 2D vector. I'm sorry, vector 2D. Which we can break. Now, we want to make a 3D vector out of this. So we'll do make vector, just make a regular vector, and then x and y, and we can leave z alone because we don't really ever care about the up and down when we're looking, just in rotation. And what we want to do with this is we want to take this value and we want to make a rotation out of it. And to do that, we are going to use a node called make rot from x. And you can see this outputs a rotator. So real quick, let's just look at what this node kind of does. It's supposed to open up my notepad and wait for it to load. Okay. And all make rot from x, or well, there's other nodes. There's make rot from x, make rot from y, make rot from z. But really, again, all this does is it takes that default x-axis. So in this case, what we think of as the forward vector. And we give it one location. And it is just going to give us the rotation to get this forward vector pointing at it. So if our forward vector was facing this way, and this was the point we wanted to face at, the resulting rotator would point like that. Same thing, if our forward vector was here, the resulting rotator would point like that. So unlike the look to rotation, which takes a to and a from, or a to and a target, I'm sorry, it is a from and a target. Yeah, our look at rotation takes a from value, which is where we want to go from, to where we want to go to. Instead, the make rot from x only takes a target, and its from is the forward x-axis. So it is like the forward axis. So that's all it's doing. And if you think about it, we have our character, they're facing a direction. Our controller input will be, on this axis, it would be 1, -1, 1, and -1. So depending on where we are, all it's going to do is take this forward vector and give us a resulting vector pointing towards wherever our controller will be pointing to. All right, so let's go and use this node. So we want to make rot from X, and we will make a new variable, and I will just call this look at rotation. We're going to make this a rotator. And let us set this. So all we're doing in this function is we're just updating what this rotation wants to be at, and we're actually going to set this again in the tick event. So I go back to our event graph, and when we trigger the controller, well, we want to call this update aim rotation, and what do we want to call this at? Well, we want to call it at these action values. Okay, and then now down here in the in our tick event, if it's false, so for not using the mouse, so this is just for using controller. If you guys are only using controller or mouse, you don't need to do both of these. Just do the one that works for you. We are going to do the same thing. We want to set the actor location. I'm sorry, we want to set rotation. What do we want to set the rotation to? Well, we're just going to do the same thing. We're going to rinterp, and we're going to set it to this interp value. And the interp value is going to go from our current location or rotation to this look at rotation, with the delta time being this get world delta seconds. And I'll use the same interp value of 25 here. Great. So now if I connect my controller up and go back to the level, hit play, wait for everything to load up, and it works. It follows my cursor or my control stick, but if you were actually trying this, you would notice that things are a little weird. It's not exactly following my control stick, so I'm pointing my control stick to the right and my character is looking up. When I point it down, it looks right. So everything is kind of rotated 90 degrees in the wrong direction. There's a very simple fix to this in our update aim rotation function. All I'm going to do, oops, not promoted to a variable. Let's delete that. Okay. All I'm going to do is take this return value, split the struct pin, and we're just going to make a new rotator. So make rotator. And all I'm going to do is add 90 to the z-axis, because that's how much it was offset by. It was offset by -90. So if I add 90 to it, that should fix the issue and make it much more smooth. Or, well, make it right, correct. And so now if I point my controller to the right, we're looking right. If I point it down, we're looking down. Left is left and up is up. So this works fine. I can even move my character around, and that works fine. Now, one more small issue is, and this again comes down to your game design, but if I point my character up and I start moving and then I let go of up, I want my character to face the direction they're moving. I don't want them to keep looking up. I want my player to have to hold the control stick when they're aiming, and if they let go of the control stick, I want them to be looking in the direction that they're moving. So let's do that first, or let's do that next. And what we really want to do is, well, first, if we want to make a new Boolean here. I'm going to call this Boolean looking. And all this is going to represent is if our character is currently using the right stick and if they're looking. So this is where I'm going to delete these print strings for now, and this is where the completed action comes into play. So when we trigger it, we set looking to true. And when it's completed, we set looking to false. So now only if we're hitting a key is this looking variable going to be, or I'm sorry, only if we're holding the right stick will this looking variable be true. Otherwise, it's going to be false. And we can use that here, where even before we check for this hit result, let's make sure, oh, that's the wrong one. Even before we set this actor rotation here, let us check if they are looking. So only if they're looking are we going to set the rotation. Otherwise, we're not going to bother. If they're not looking, I want them to orient to the direction of the movement. That is something our character movement has built in. So I am just going to pull out our character movement and then search orient. And there is set orient rotation to movement. So when it's triggered, it's going to be false. And if we're not using if we're not using the right stick, then we want it to be true. And now we can go test it. Let's go back to our level and hit play. All right, so now if I move my mouse, or I'm sorry, if I move the right stick, I look around. If I hold my right stick down, I'm moving up. We're looking down and moving backwards. If I let go the right stick while moving up, we switch to moving up. And now I'm not touching the right stick. My character is going to be oriented in the direction they're moving. But the second I touch the right stick again, I'm going to move it left. We can see our character flips and, they aim in the direction they want to. When we let go of it, they start aiming in the direction they're moving. This, again, makes our game look much nicer. It looks more professional, feels much nicer as well to play. But that has been how we set up our twin-stick shooter to work with controller. It's a slightly different logic, but basically the same concept. We're just giving it a spot, and we're telling it, hey, I want you to turn to that direction. We're using set actor rotation in both cases. We're using the interpolation in both cases. The only real big difference comes from with the mouse, we have to raycast and do a fine lookout rotation because we're using a raycast. And with the controller, because we're using kind of more abstract values, we're using the controller axis values, we just make a rotation from X. We're just telling our character's forward vector where we want it to rotate. Anyway, this concludes our basic setup for our character. There's a lot more we have to do. We're going to have to add a character, or like a character mesh into it, give it some animations, maybe add a shooting mechanic, as well as get some enemies working. But this has been simple enough. We've set up a character, we can make them move, we have them look, and just like we did with the first person character, you can also add like a sprinting feature just by changing their run speed, and we can use these same we can use all these options here to customize our player to make it how we want to make them. You could even go ahead and add a jump feature. I'm not going to add one because with twin sticks, it's not something you traditionally have. You could add a dash feature as well if you want. But all of that is very similar to, or it's basically the same as on how we did it with the first person character. The real difference comes in with, setting up a camera with a spring arm and then the controls itself. Anyway, that's been the entire setup for our twin stick character. Thank you guys for watching.